Hello and welcome to another video of a math solution, which I'm going to try and show you. I'm trying to do this on GeoGebra as well, which is a little bit different, mainly because this is a graph drawing one really, and the graphs aren't that difficult to do. It's quite subtle though in places towards the end, it's a math question after all, but it starts off really easy. So let's see, we've got a quarter disk of points x, y. X is greater than or equal to 0, y is greater than or equal to 0, and x squared plus y squared is less than or equal to 1. In other words, they're saying x and y is trapped in this quarter circle here. Yeah, it's trapped in that region. And as drawn in figures A and B below. And they wanted you to actually annotate these, which is fine. So you're going to have to do this without, graph software drawing, but it just makes it look a lot neater when I do this, because I wanted to show you several things. Okay, on the axes in figure A, sketch these graphs. X plus y is a half, x plus y is 1, x plus y is 3 over 2. They're, of course, going to look like this. I'll just put them on, because if I'm sketching x plus y as a half, I just say when x is 0, what is y? It's a half. When y is 0, what is x? It's a half. And I draw a straight line through it. It really is that simple. You can see it's a straight line. It's a linear equation. Same for x plus y equals 1. Same for x plus y is 1.5. And in fact, can I just quickly show you this, that generally speaking, it's nicer to look at it like this. Look, I've got here the graph x plus y equals c, where I'm going to change the value of c up here. What does it do when you change that number? It just pushes it out, but keeps the gradient the same. Yeah. Now, this first question is find the largest value of x plus y. In other words, the largest value of c in my x plus y equals c formula here, or the largest value of this number on the end, so that the line remains with at least 1 point in the quarter circle, because we want x and y to still be in Q. Yeah, at least 1 point in Q. So I'm going to try and make it as large as possible. And you can see on my diagram, it kind of happens here. And I hope you can see from the symmetry that what we need therefore is, now let's try and draw on this screen. I think I can do it. This point out here, which lies on the line y equals x. Now, you should get really quick at finding points like this. I hope you can see relatively quickly that that's going to be 1 over root 2 across, 1 over root 2 up, because you want that length to be 1, because this is clearly a circle with radius 1. So what you've got here essentially is 1, x and x, but we see this so many times in maths, this particular right-angled isosceles. And if you solve x squared plus x squared is 1, you're going to solve 2x squared equals 1. And so x is going to be 1 over root 2, and y is going to be 1 over root 2. And so the answer to this first question is quite simply, because we want to know the largest value of x plus y, we're still going to add these two together. So you're going to get 1 over root 2 plus 1 over root 2, which is 2 over root 2, which is just root 2, because 2 divided by anything divided by the square of itself is just a square root of itself. Think of it as 2 to the 1 divided by 2 to the half, subtract the powers. We get root 2. So that's the answer to part 1. I thought that was a really easy start to one of these questions. I haven't seen one quite as easy as that for a while. Can I do this a bit quicker than slowly undoing everything for ages? Probably yes, but is there a rubber on here on this? I don't know actually. Let's just keep undoing it. I'll get there in the end. Oh, I can press Control Z. Let me do that then. So Control Z, Control Z. There we go. I'm getting rid of it quicker now. I've just figured it out. So that first answer should be root 2. Yeah. And yeah, it's all about finding the last value on there. And actually, the second question is all about that as well, because if you look now, what have we got next? We've got, let me just move around the screen 1 second. There we go. Next, they want us to draw the line xy equals equal, xy equals 1, xy equals 2. Now, really, if you rearrange these are of the form y equals k over x, if you see what I mean, because this is going to be 1 over 4x, this is going to be 1 over x, and then this is going to be 2 over x if you rearrange it to make y the subject. So you really want to know what the graph y equals k over x looks like. And it's not difficult to draw, it really isn't. If I just rearrange this one to make it xy equals c, but you should be able to do this. Now, where's that got? Oh yeah, because I've got to change this. Change that. y equals c. Okay, and then let's show you the graph. Where's x, y equals c? I thought I'd hang on a second. Let me just figure out what's going on with the GeoGebra. I think I might have just made it crash there. Probably. Can you not show me that one? Let me just delete that. Let me try again. X, y equals c. Doesn't seem to like that. Why not? It should like it. Y equals 1. Well, y equals c over x. Can we try that? There we go. It's drawing it now. I don't know why it didn't like putting it in like that, but there we go. Sometimes GeoGebra can be a bit weird. But this is what, as you increase the value that x, y equals this time, you just get further and further and further and further out here, yeah? But we want it to still be in the circle, yeah? And we want it to be as large as possible. Well, clearly, when we make c bigger and bigger and bigger and bigger and bigger, it's going out here. But if you want x, y to still be in this region, then you'll make it kiss just there, so that you're making x, y as large as possible, but you're still picking a point so that it's in Q. Well, this is exactly the same coordinate as it was before, yeah? The coordinate is going to be, if I can just write it down again, 1 over root 2, 1 over root 2. There's no point in us finding that again. And as we're doing x, y, well, that's going to be 1 over root 2, 1 over 1, times 1 over root 2, which is a half. And so we can see that we're going to be maximizing x, y at least when x, y equals a half. Now, how does that help us with our question? Well, it helps us because what have we got to find here? We've got to find the largest value of x squared plus y squared plus 4xy. So that looks a bit different because all I've spoken about is how to maximize xy so far. But x squared plus y squared is always true on the edge of this. And if you want to maximize x squared plus y squared, but you have to follow the condition that x squared plus y squared is equal to 1, less than or equal to 1, sorry. And remember, we're maximizing it. We're going to make it as large as possible. Then we want to be on the edge of this circle, don't we? Which means, yeah, it is going to be maximized at that point, yeah? And at that point, x squared plus y squared equals 1. And xy equals a half. So what we have here is 1 plus 4 times a half, which is 3. So that's dead easy, really. Write down this 1 plus 4 times a half, which equals 3. Yeah, and that's so much easier if you really understand graphically what's going on. Now, this one took me a little bit more thinking because it's not necessarily going to lie at the same point. Sure, x squared plus y squared, subject to x squared plus y squared being less than or equal to 1. The largest you're going to make that is going to be 1. Yeah. The problem is, if you were to say naively, okay, let's make this as big as possible by using 1 over root 2, 1 over root 2 again. Don't forget, we're taking this away. And that was a half, remember, times by 6 is 3. So we're going to take away 3 there. So we're going to have 1 take away 3, which is minus 2. Now, immediately, when you sort of test points, you kind of realize, well, that can't be right because I can do better than that if I just pick 0, 1 or 1, 0, because I want to make, if I'm maximizing this, the first thing I was thinking is I want to make that as small as possible. And I know I can make it 0 because if x is 0, y is 1. And if x is 0 and y is 1, and this is 0, then you're going to have 0 squared plus 1 squared here. So you're going to have 1 minus 0. And I thought immediately, well, that sounds like a much better answer to me because the biggest I can make x squared plus y squared is 1. And that's the case all the way around on the edge here, yeah? But when you get to this value or this value, what's the value of xy there? Well, it's actually 0, and it's where this kind of equation breaks down, really, because you're doing 0 times infinity, like, you know, in a loose speaking kind of way. But yeah, if we use this value here, we can certainly achieve a value of 1 for this, which is clearly going to be the highest value. So we're going to have 1. Oh, I'm moving that around now. Apologies. Let's get the pen out here. We can make this as small as 1 and that as small as 0 if we use 1, 0, but equally 0, 1 will do. Yeah. And so the maximum value of that is 1 because you're always going to be taking away positive times a positive there. And so, you know, that's the best you're going to be doing If you can see the shape of the curve shows you that as well. So yeah, it's a tricky one. That one it takes a little bit of thought. I suppose another way of doing it, another way of thinking about it might be to even take the C into the negative zone. Yeah, where you're thinking it's really there when C is 0, which you want. Yeah, when C is 0, when you've got yeah, xy equals 0, then you can make this up to 1 basically, and so it's like it's where it collapses the curve because you've really got y equals 0 here. But yeah, it's subtle to think about that. It really is. It's a little bit harder, but you can probably get there just by common sense. That's what I would argue with that one. Okay, here's a really interesting bit. I quite like the last bit. This is where it got a bit more interesting, a bit more difficult, and a bit more like some of the stuff that you do with loci in the complex numbers chapter. So let's have a look at this. Okay, let me just get rid of some of my pen. Let's try and undo here. So I'm just getting rid of my writing. I'm really stressing the computer out at the moment as well. Good, still recording. That's it, just get rid of that. Okay, cool. Right, now, for the last part, the very first bit is no problem at all because it's typical. I would describe it as a typical AS style question, yeah? What is this curve? Well, you should be really used to now the idea of completing the square twice to produce, lo and behold, a circle. Because you're going to get x minus 2 there squared. That will give you the x squared minus 4x, take away a 4 plus y minus 1 all squared, take away a 1, equals k. And so what does this represent? It represents a circle, center 2, 1, radius k plus 5, which is why they've got k is greater than minus 5. So circle, center 2, 1, radius, root k plus 5. And that's described it nicely. Now, this time we're trying to minimize an expression which looks just like that. So we're trying to minimize k here, really. But we can use this idea of the circle because we're trying to minimize this, making sure, though, once again, that these points are definitely in Q. It's the smallest value found by this expression whilst these points are in Q. So that's what I'm going to try and do. I guess first thing first here, I'm going to actually draw that circle. And once again, I'll use the C as my, so let's get rid of xy equals C. Well, where is it? Where's that equation which I wrote in? I think it's here, yeah, that function. Okay, right. So I'm going to write down this time x squared. Oh, no, sorry, x, let's put it in brackets, x minus 1 squared. Was it x minus 1, x minus 2, I think it was. Apologies. Plus, if you haven't got GeoGebra on your computer, what are you doing? It's free. Get GeoGebra equals C. Cool. Okay, right. So I've got the circle here. It's center 2, 1. And if you like, I'll put a little dot there so you can see that. It's center 2, 1. I'll take away that annoying D. And I'll take away that label as well. It's a bit annoying. And as I change the radius of the circle, obviously, eventually, I'm going to be just about touching the disk which I need to be in. Yeah. Now, what is this equation? Let's just write it down again. The equation of this is x squared minus 4x plus y squared minus 2y. Now, actually, this is x squared plus y squared. Well, actually, let me write it down in a different way so it's less confusing. Let me just get rid of that. Let's write it down as x minus 1 all squared plus y minus, I keep writing it as x minus 1, it's actually 2, apologies, y minus 1 all squared equals k plus 5. That's this equation. I've called it C up here, so apologies for that. I've called it C. Can I cross that out? Like k plus 5. That's what k plus 5 equals if I use this little slider. Okay, so obviously, what I'm doing here, if I'm trying to minimize the value of x squared minus 4x. Let me just write down the question again. Minimize x squared minus 4x plus y squared minus 2y. Yeah. Now that's not exactly the same as this, because if I was to multiply out these brackets on the left-hand side, I would actually have an extra plus 5. Yeah, let me just write down underneath. You'd have x squared minus 4x plus y squared minus 2y. You'd actually have the plus 5 here. But that's okay. Yeah, yeah, it's plus 5. That's okay, because this will be minimized when this one is minimized, because it's just 5 greater than this one. It just means I need to take away 5 at the end of the question, really. And this will be minimized looking at this diagram, and this is where we get the clever bit, when this circle is just about in this region. Yeah, it could be bigger than that and get bigger and bigger and bigger, but that would be increasing k plus 5, because as I increase this, the circle grows. Yeah. And so that would increase this, which is no good, because I want to minimize it, but still make sure that it's in this disk. So that's going to take place there. Now, the problem is that isn't exactly at the 1 over root 2, 1 over root 2 ones. That's at a different point. But the good news is we can work out where it is. And actually, we don't even need the coordinates. I think in the mark scheme, it gave you the coordinates, but you don't need them. You really don't. Because we can work out a lot of things on here. We've got a lovely little right angled triangle there. That length from there to there is 1, for obvious reasons. This length from here up to here, well, as that's a 2 and that's a 1, all of that will be root 5. And so this is going to be root 5, take away 1. So what have I found here? I've found that the radius of my circle needs to be root 5 minus 1. Now that's what this equals, yeah? So I can say x squared minus 4x plus y squared minus 2y plus 5. Well, that's the radius, so I need to do root 5 minus 1 and square it. Now, if you work that out, that's going to give you 5 plus 1, which is 6 minus 2 root 5. Check that you understand why that is the case. And so we've got x squared minus 4x plus y squared minus 2y plus 5 is equal to that. And then as I want to minimize this expression, and I don't want the plus 5, I need to take away 5 at the end. So all I'm going to have here at the end is, sorry, just trying to get this right, that x squared minus 4x plus y squared minus 2y has a minimum value subject to the conditions that we had of 1 minus 2 root 5. And that is the minimum. And it's just because we want to make that radius as small as possible. But I didn't need to work out that coordinate. I think it mentions it in the mark scheme, but I didn't think it was particularly relevant. But yeah, I hope that makes sense. I hope I've justified it enough as well. It's tricky for me to do actually writing on GeoGebra, but I hope it makes sense. Hope you appreciate the video. That was just my take on question 4 of the 2011 math question. Yeah, best of luck with the math. I know it's hard. Keep practicing.